Welcome back to MPB. I am Ms. Killen. We are in Unit 4 still, but I really want us to do some refresh and review with our expressions before we get into some more meat of our working with functions. So let's look and see what we've got. It says what to do when you need to multiply polynomials. Now, some things that we need to understand is our FOIL method, our box method. We need to be able to understand what's happening when we are multiplying our coefficients. We need to know what's happening when we're adding those exponents when we're multiplying. So that's what we're really going to look at and review this lesson before we get into some more meat of the matter. So you're looking at this screen and saying, Ms. Killen, that looks like tinfoil, and you would be exactly right. The reason I have shown the tinfoil slide, I have always encouraged my students, get some tinfoil, get aluminum foil, whatever you call it, and write our steps on there. You may be thinking, but why? Okay, how many pieces of aluminum foil do you keep in your binder? You will see that aluminum foil and you will say, okay, first I do this, next I do this, next I do this, and then last I'll do this. It's just a reminder tool, or maybe it can be an organizational tool that we can use with our FOIL method. So let's look at that FOIL method, and then you can, if you want to, write it on a piece of aluminum foil. So we're going to use these two binomials and we're going to multiply them. When we multiply them, we're going to use this FOIL method. So I'm going to write them in different colors so we can see the steps along with what they mean. So my F means my first terms. And when I say my first terms, I'm multiplying. So I'm going to use arrows to show my first two terms that I am multiplying. 3x times 5x gives me 15x squared. When I multiply my coefficients, I am adding my exponents. If I don't see an exponent, it's an understood 1. 1 plus 1 is 2. The next term that we are going to work is our outer terms. Now you're probably saying, what do you mean by outer term? The terms that's on the outer part of this expression. We're going to multiply those. 3x times a negative 2 is a negative 6x. The next one that we're going to look at is our I, which is our inner terms. Now, inner means inside. So the two terms that are inside of our expression. 4 times 5 is a positive 20x. And then we have our last. And we're going to call it our last terms. And it's the last ones in both binomials. 4 times a negative 2 is going to give me a negative 8. Now, with everything that I do with expressions, with polynomials, I always want to put like terms together. So let's see what putting like terms together does to our polynomial. Let's look. Negative 6x plus 20x is going to give me a positive 14x, and then I'm going to bring down the rest of my expression. So I've taken two binomials, multiplied them together, and I've got my trinomial. Putting my like terms together, because I always do that, and I've gotten 15x squared plus 14x minus 8. And I've used the FOIL method. So let's look. I have another example. I want to use that FOIL method one more time. So let's go ahead and try it. My first 6x times a negative 3x gives me negative 18x squared. Then I'm going to go to O, my outer terms, the 2 that's on the outside of my whole expression. It's going to give me 6x times a negative 5 would be negative 30x. The next one that I have is my I for my inner terms, my two interior terms. Negative 4 times a negative 3x is going to give me a positive 12x. And then I have my last one, which is going to be my L. And those are my last terms in both of my binomials. -4 times a -5 gives me a +20. Putting my like terms together, which would give me a -18x, and then bringing everything else down. So I've taken two binomials, plugged it into my FOIL method, and I've gotten a trinomial. You always want to make sure that you're putting like terms together. You always put them together so you have them in simplest form. Always. So let's look and see what else we got. Our next one is our box method. Make a box with expressions on top and the side. Split each term on top and on the side. And then you're going to multiply top to side and then add diagonally. Now, let's see what Ms. Killen's talking about. So I'm going to take this first binomial and split it up. My first term, my second term, that second binomial I'm going to split up, 5x, and then -2. Now, you may be sitting there wondering, Ms. Killen, why did you put the addition sign? Why did you put the subtraction sign? Because in these terms, they showed us what each term did to one another. But when I am using them to multiply, they're going to tell me if they're positive or if they're negative. That's why I always put them on top of my boxes. All right, so let's go ahead and use this box to multiply. Here we go. 3x times 5x is a -15x squared. Remember, I'm always adding my exponents. 5x times a +4 is a +20x. -2 times 3x is a -6x. And then -2 times a +4 is going to give me -8. Now, I'm not done. It tells me to add diagonally or corner to corner. So corner to corner, I'm adding. Corner to corner, I'm adding, and I get -6 plus +20x would give me a +14x, and then corner to corner gives me -8. So I have gotten another method in how I can multiply these binomials. So there's another tool in our toolbox to help us when we're multiplying these binomials. So let's look at some more examples. It says, try another example. Use the box method. So I'm going to go ahead and work this on the board in real time. You work it at your table or station, and then let's compare. X minus 4. -3x minus 5, multiplying top to side, 6x times a -3x gives me a -18x squared. -3x times -4 gives me a +12x. -5 times a +6x gives me a -30x. -5 times a -4 gives me a +20. Going then to add corner to corner, the first one, -30 plus 12 gives me a -18x, and then I'm left with 20. So look at my work, look what I did, look and see what you did on your paper. Did we get the same thing? Did we have the same symbols? You always want to make sure that you remember those rules of when you're adding like terms, or when you're adding a negative and positive, or maybe when you're multiplying negative and negative and positive, positive, or negative to positive. We've got to remember what those rules are that we've already learned. So our next one says, use either method for this problem. You use what method is comfortable to use. I'm going to go ahead and use FOIL method. So I've got my first, which is -x times 4x is going to be a -4x squared. My outer terms is going to be a +10x. My inner terms is plus 28x. And then my last terms is going to be a -70. Always putting like terms together gets me a +38x. and then bringing my other terms down. Check my work, check your work, see about the signs, about putting like terms together, and seeing what you did when you multiplied those coefficients and had to add those exponents. You have to keep all these in mind, making sure that you're doing them correctly. Good job. All right, so let's see what we've got next. It says multiply these polynomials using both methods. Compare which method you like best. So go ahead and pause the video. Try the FOIL method and the box method. See which one is best for you, and then come back to me. I'm going to work, you work, and we'll see what happens. All right, so I've got my FOIL method already done, multiplied my terms, put my like terms together. I got negative 48x squared plus 28x minus 4 with my FOIL method. Now, let's see if my box method will get me the same answer. You try, and then I'm going to try. Negative 3x plus 1. 16x minus 4. So I've got a negative 48x squared. I've got a positive 16x. I've got a positive 12x. And then I've got a negative 4. Adding corner to corner, I get negative 48x squared. 12 plus 16 is a positive 28x. And then my negative 4. Now let's compare these answers. My FOIL, negative 48x squared plus 28x minus 4. My box, negative 48x squared plus 28x minus 4. So two different, completely different methods, but I got the same answer. Depending on which method you use, depends on which method feels more comfortable and more safe to you. You may be able to do FOIL, it's the best thing ever. You may be able to do box, it's the best thing ever. It does not matter which one you use. Even on test questions or even on examples that we're going to do in some of our practice in this course, it's not going to say use only this or use only this. They're going to care how you're multiplying and what answer you're getting. So the one that's the best fit for you, that's the one that I'd probably try and get proficient at. All right, so let's look at some more. It says you can use the box method easily when you have different exponents. Here's a hint. It says multiplying coefficient, adding exponents. Your longest expression's on top. You can still add corner to corner. You can only add like terms. So we have an expression up here. We have a trinomial times a binomial. So let's go ahead and build our box. Now, it said over here on the side, it said longest expression on top. So I've got 3 terms, so I'm going to go ahead and do that. And then I'm going to put my binomial on the side. And here we go. X squared plus 6x minus 5. I am still putting my addition or my subtraction sign to make sure that I understand what's positive and negative. Now let's put the binomial. X minus 1, multiplying from top to side, and I get x squared times x is going to give me x to the third because I'm adding my exponents. 6x times x is going to be a positive 6x squared. Negative 5 times x is going to give me a negative 5x. Then I go to the next term. X squared times a negative 1 is negative x squared. 6x times a negative 1 is negative 6x. Negative 5 times negative 1 gives me a positive 5. I'm still adding corner to corner. Don't let the 3 columns fool you. Still corner to corner. My first box, x to the third, this corner, negative x squared plus 6x squared is going to give me a positive 5x squared. Negative 6x plus a negative 5x gives me a negative 11x. And then my last box, plus 5. This is my answer. Now, when I look at this method, I should see that when I added like terms. I added my x squares, I added my x's, and then I had just my x to the third, and then my constant. You always want to make sure that you are adding or subtracting like terms, no matter what method you do, no matter what method. Okay, so let's do some practice. Evaluate the following. So I'm going to work and you work. So the first thing I'm going to do is build my box. I have a trinomial times a binomial. So I have, let's go ahead and change, 3x squared plus 3x plus 3, 2x minus 4, multiplying top to side, and I've got 6x to the third. Multiplying top to the side, I get plus 6x squared. Multiplying top to side, I get plus 6x. Then I go to my next term. I have 3x squared times a negative 4, I get negative 12x squared. 3x times negative 4, I get a negative 12x. And then negative 4 times positive 3 gives me negative 12. I am still going from corner to corner with my addition. So I have 6x to the third. Negative 12 plus 6 gives me negative 6x squared. Negative 12 plus 6 gives me negative 6x. And then I'm left with my constant at a negative 12. So 6x to the third minus 6x squared minus 6x plus 12. Check your work, check my work, see if you got the right symbols, see if you got the same positive or negatives. Check out when you added corner to corner. Make sure that everything is in a row, that you have your like terms. All right, let's do the next one. Here we go. All right, so I'm gonna make my box up here. And I've got 3 terms is my largest. Then I have my binomial. I'm gonna put 4x squared minus 6x plus 1. I'm gonna put 6x minus 7. And then I'm gonna multiply from my top to my side. So 4 times 6 is 24. 2 plus 1 is 3. Negative 6 times a positive 6 is a negative 36. 1 plus 1 is 2. And then anything times 1 is itself. Negative 7 times 4 is a negative 28, bringing down my x squared. Negative 6 times negative 7 is a positive 42, bringing that x down. Anything times 1 is itself. Now I need to add corner to corner. So I've got my 24x to the third. Negative 28 plus a negative 36 is going to be a negative 64x squared. Positive 42 plus 6 is going to be a positive 48x. And then I have my constant. 24x to the third minus 64x squared plus 48x minus 7. Check out my work. Check out how I put my negatives and positives together. Check out how I added like terms and make sure that yours looks like mine. We want to always make sure that we put that largest expression on top because it's just easier that way. Now, if you want to try it the other way, it'll work just fine. I do it this way because it's easier for me. It's all about how you're comfortable doing the math, okay? Never be afraid to try something because that way may be the easiest for you. All right, so let's look. Watch out for missing terms. You must show all degrees in your expressions. Now, Ms. Killen, are you talking about it 82 degrees outside? No, I'm not. When we talk about degrees in these expressions, to the 5th degree, to the 4th degree, to the 2nd degree, to the 1st degree, whenever I start an expression, whatever my highest degree or my highest exponent, I have to show all of those degrees. Now, how am I going to add something to an expression and not change the expression's value? You're right, you're going to add a 0. Anything times 0 is 0, so you're not necessarily adding a value, you're holding a place. So let's see. I have this trinomial. I have a 5th degree, 2nd degree, and then I have my constant. So if I was going to use a box to multiply these two, this is what I would do. I would have 4x to the 5th. There is nothing to the 4th. There is nothing to the 3rd. There is something to the 2nd. There is nothing to the 1st. And then I have my constant. If you need to show up here what the degrees are, that's perfectly fine. So now let's put my other term on the side. I have an x to the 2nd, I have nothing to the 1st, and then I have my constant. So let's go ahead and multiply top to side. So here we go. 4x to the 5th times x squared is going to give me 4x to the 7th. Anything times 0 is 0. Anything times 0 is 0. Negative x times a positive x is negative x. 2 plus 2 is 4. Anything times 0 is 0. And then 7 times x squared is a positive 7x squared. Anything times 0 is 0. So I'm just going to put this here as my placeholder. Then let's go to that last constant term. 4x to the 5th times a positive 2 is a positive 8x to the 5th. Anything times 0 is 0. Positive 2 times a negative x squared would give me negative 2x squared. Anything times 0 is 0. Positive 2 times a positive 7 is a positive 14. Now, stop. Everybody needs to make sure, even though we have a whole bunch of zeros and we have a whole bunch of boxes, we are still adding corner to corner. We are still adding only like terms. So we got to make sure that we pay attention. Let's look and see what I do. Here we go. Corner to corner, 4x to the 7th. 0 plus 0. 8 plus 0 plus 0 is going to be a positive 8x to the 5th. 0 plus 0 plus a negative x to the 4th. 0 plus 0 plus 0. Negative 2 plus 0 plus a positive 7 gives me a positive 5x squared. 0 plus 0, and then I have my constant. 4x to the 7th plus 8x to the 5th minus x to the 4th plus 5x squared plus 14. I put those zeros there to hold place values of numbers that were not into this problem. We always want to make sure that we are careful with those zeros. Okay, we're not adding exponents because anything times 0 is 0. We always want to make sure of that. Always, always. So let's look and see. It says, don't forget our FOIL method. We use our first two terms, our outer two terms, our innermost terms, and then that last term. When I use that box method, I'm splitting the terms on top and I'm splitting the terms on side, and I'm multiplying from top to side, and then I'm going to add corner to corner. When you have different exponents, you add the exponents when you're multiplying the coefficients, and you're always making sure every degree in the polynomial is present when you are multiplying. Thank you so much for coming to learn with us here at MPB. I'm Ms. Killen. I want you to have a great day.